So in the last video, we had established the formulas for the basic trigonometric ratios. In this video, we will try to find the values for the standard angles that are common to triangles. So triangle specific, trigonometric, now the first basic type of triangle is an equilateral triangle. An equilateral triangle is a one wherein all the sides are of equal length. That is, if we denote this equilateral triangle by ABC, then the side opposite to angle A is denoted as A, and all the sides are equal to this value. So all the three sides are A. In such a triangle, the angle are equal as well, and they are equal to 60 degree. So A is equal to B is equal to C is equal to 60 degree, and similarly A is equal to B is equal to C is equal to some value A. So the first angle that is very frequently observed in case of triangles is 60 degree or pi by 3. So this equivalence of pi by 3 and 60 degree has been derived in the earlier videos. The second type of triangle is an isosceles right angle triangle. Now, an isosceles triangle is a one in which two sides are equal. An isosceles right triangle is the one wherein, apart from the two sides being equal, one of the angle is 90 degree. So obviously, from the Pythagoras theorem, we know that the hypotenuse is the largest side. So consequently, the legs are the ones that are equal. So let us denote them by A, and the hypotenuse by B. And we know that B square is equal to A square plus A square, or simply B square is equal to 2A square. B is equal to under root 2A. Now if at this point if you are not familiar with irrational numbers like root 2, then I would suggest that you consider it, just accept it for the sake of it, or if you want to dig deeper, then obviously you can Google it or GPT it or look into some books, or you can maybe look up our videos on class 9 mathematics where we explore this term in detail. So this B is equal to root 2A. Now in a triangle, the sum of the three angles is 180 degree, and consequently another theorem that I want to establish here is that the angles opposite theorem. The angles opposite to equal side are equal. And the converse of this theorem, the sides opposite to equal angles are equal. Now it is possible, it is very possible that that as I go on further in the video, I would be using concepts that are not pertaining to may not cater to the syllabus of your class, but because we are covering foundational JEE mathematics, hence we want to build the depth for it, and whenever I feel that you may not have the background to understand the concept, I will provide the theorem, and your task on the other hand is to look up the derivation for the theorem, or maybe some basic applications. Obviously, whenever a question comes utilizing the theorem, I would iterate it again. So the consequence of the theorem is that the angles opposite to equal side. So the two sides that are equal are AB and BC. Consequently, these two angles are equal. Angle A and C are equal. Let them be x. And we know that in a triangle, the sum of the angles is 90 degree. So, sorry, the sum of the angles is 180 degree. Consequently, the value of x comes out to be 45 degree. So 45 degree is another very common angle which is observed in case of triangles. Third is a very specific type of triangle, again very commonly observed. It is a type of a right angle triangle wherein one of the angles is either 30 degree or 60 degree. So consider a triangle ABC wherein let the angle C be 60 degree and the triangle be right angled at angle B. Now you can clearly observe that angle A comes out to be 30 degree to make the sum 180. So this type of triangle again is very frequently observed, and the third common angle which is observed in case of triangles is 30 degree, which is denoted as pi by 6, and obviously 90 degree is again frequently observed. So now the values of the trigonometric ratios. So you have sine theta, cos theta, and tan theta, right? And this is be the column for theta. Now let's start with the smallest angle. You have pi by 6, which is 30 degree. Sine pi by 6 is 1 by 2. Next we have pi by 3. Sine pi by 3 is, sorry, the next smallest angle in the ascending order is pi by 4, 45 degrees. 1 by root 2. Then we have pi by 3. The value of sine pi by 3 is root 3 by 2. And then we have pi by 2. The value of sine pi by 2 is 1. Now coming on to the cos function or cos theta. So in a cos function we observe that now clearly when you input this into a calculator, you will observe that this is an increasing function in the sense that these numbers are in ascending order. So basically what I mean to say by an increasing function is that as you increase the input, because obviously 30 is less than 45, which is less than 60, and which is less than 90. Consequently, the values, the output of this function, imagine the function as some form of a black box wherein there is some operation called sine theta. You input a value which is theta, and you get the ratio. So when sine theta is operated, you'll observe that this value increases as the value of theta increases. So we say that sine theta is an increasing function between 0 to pi by 2. Although 0 is not common to a triangle, obviously in a real triangle it's not possible to have one of the angles as 0 degree, but because the values of trigonometric ratios corresponding to 0 is important, so I'll put it on top of the table. So let's just adjust it over here. So 0. I'll mark it by blue. The value of sine 0 is actually 0. So basically what I wanted to highlight is that between 0 and pi by 2, sine is an increasing function. Now value for cosine. A value of cos 0 is actually 1. The value for cos pi by 6 is root 3 by 2. The value of cos pi by 4 is 1 by root 2. The value for for pi by 3 is 1 by 2, and the value for pi by 2 is 0. So you see that it now increases in the reverse order, or we can say that between 0 and pi by 2, cos is a decreasing function. And lastly, tan theta is simply the ratio of sine theta and cos theta. So you take the ratio of the two. You can pause the video for a minute so that you become much more familiar with these ratios. Now you can see that tan pi by 6 is 1 by root 3. Tan pi by 4 is 1. Tan pi by 3 is root 3. And tan pi by 2 is 1 by 0, which is undefined. Often people write 1 by 0 as infinity, but a much more accurate or a mathematically correct term is undefined. And obviously tan 0 is 0. Again, I want you to pause the video for a minute and input these values into a calculator, a scientific calculator. When you do so, you'll observe that again from 0 to pi by 2, it is an increasing function. So these 4 and 5 angles are very commonly observed in triangles. You'll be very frequently observe them in questions or the modules that we give you.